Welcome everyone to today's webinar. My name is Scott Mizek, Senior Technical Specialist here at ATG. The topic of today's webinar is Subassembly Composer, pulling horizontal from a vertical target. What that basically means is I'm going to be able to set the width of my lane based off of a proposed profile. This webinar is being recorded, so it will be put up onto our website here shortly. If you have questions, feel free to put them into the chat. If I feel that the question is pertinent to what I'm talking about right then and there, I will go ahead and stop, address the question, and then move on. If I think the question can wait to the end of the webinar, I'll go ahead and address it at the end of the webinar. But feel free, ask questions. Let's go ahead and get started. A little bit about myself. I have a Bachelor's of Science in Geography GIS from the University of Minnesota. I got that back in 2010. I have spent the last 8.5 years in the Autodesk reseller industry. So I've been a consultant, I've been a trainer, I've been that person you need to do some work. I've done it all for a wide range of companies, for a wide range of projects. Prior to that, I spent 6 years in the surveying industry as a level 3 construction certified survey crew chief. I have been using Autodesk products since release R13, not 2013, but R13. So that puts me at about 29 years of using Autodesk software. That does make me feel really old. My experience is working with civil engineering companies, surveying, and then construction firms. Obviously anything civil, anything infrastructure based. And I do specialize in Civil 3D, Map 3D, Inforx, Esri products, ArcGIS Pro, ArcGIS Online, to name a few others. I have spoken at Autodesk University a total of 6 times. And on a side note, I am a certified technical consultant and certified instructor for Bluebeam Review since 2014. So let's address the problem. I need a subassembly that I can use a proposed profile to set the width of the subassembly, or use a proposed profile to set the vertical change of a proposed profile. Why is this a problem? Anyone can build a road. Anyone can build a road if the design is set and we know it's not going to change. It's when that design changes and what does it take to get that change to occur. It's that time that's the problem. By using a subassembly composer, one can construct a subassembly that meets the requirements of that design. What I'm looking at doing is speeding up the process, and we'll talk about this later on. So in today's webinar, we're going to look at a subassembly that uses the profile for width, the subassembly that uses a profile to set just a vertical change on there, not set the elevation, but a vertical change. To discuss the benefits of this process. And then we're going to look at some of the CTC Software's Corridor Productivity Pack to see how could we take those PKTs, make a little twist to it, and make them that much better. So where to start? We're setting the width of a segment from a profile. So the starting point comes in, and we basically I just have a generic segment in here, width, length, slope, width, depth, slope. And the typical way is we would come in and we would do an offset target, horizontal, and we would come in and set that value. Now what happens is we apply a target to a survey figure line, a feature line, alignment, or just a flat out feature line. And it now widens my width. I go from 12-foot lanes to 14-foot lanes. Maybe I'm going to a turn lane, so now I go from 14 to 26. But what happens with that design change? Well, if I'm targeting a feature line, if I'm targeting an alignment, a independent alignment, or just a flat out polyline, I now have to make edits to that to get it to be what I need. Maybe my turn lane needs to take 125 feet to widen instead of 75 feet. Maybe I'm going from 12-foot lanes to 14-foot lanes and I want to do it over 60 feet or over 100 feet, something along that line. Well, again, if it's a polyline, I have to manually reconstruct where does it widen, where does it come out completely full depth or full width. If it's an offset alignment, yes, I can come in and make those adjustments to that parameter a little bit, but even that can get a little tricky. So the typical way, target alignments, again, it's the dynamic alignments. Those are the pros. The cons are when the widenings are station-based. Updates to the alignment location. That widening works, but if now it goes from 12 feet to 14 feet, or 14 to 15, something along that line, it makes it a little bit harder to adjust the widening, especially if it's if it's 14 feet on the start side and 16 feet on the ending side. I need to now cut that widening down and build a second widening to adjust for that change in width. The profile way. For anyone that has used Subassembly Composer, this is a generic flowchart that shows me what I'm doing. First thing I'm going to do is I'm going to create a vertical target, and I just called it profile 01, elevation 24, segment width. I'm then going to create a variable called width 01, and it's a double. By default, I'm going to accept the value of 12 in terms of feet. Then what I want to do is, this is back to that flow chart on here, is I want to create a decision to see if a target has been assigned to prof 01. So that's my vertical target. And what I do is I create a decision and it says, hey, is this valid? What that means is, in your corridor properties, set all targets, is their value assigned to profile 01 or prof 01? And if it's true, it goes this way. If it's false, it goes this way. And then from there, it comes down and builds. Well, I'm going to jump back to here where I have width 01 on there. And now, if the value is true, which means it did find a vertical target, it assigns the value of profile 01 to width 01. And it's just the sequence, width 01 equals profile 01 dot value. What that means is, at station 2 plus 50, if my profile is at an elevation of 5, my value is 5, now width 01 is 5. If it does not exist, it just takes the value of W1 from my input parameters. So either way, I get a value for width 01. Now, what I do is, in the construction of the segment, I set delta X to be width 01 instead of W1. So I had an input parameter of W1. Now I set width 1. What that means is I no longer need an offset target to override, because that is being set in my decision. If there's a target assigned, it gets the profile 01 value. If it doesn't, it gets the W1 set up here. So that target override is handled back up in here, up here, true, false. I don't need to set an offset target here anymore. When I'm done, I come in and I create a profile view, left side, right side, and then the standard profile. So here's what it looks like, my road looks like, and then I drew a right, and then I drew a left. And it started out at 12 feet, went up to 36 feet, stayed at 36 feet for a while, went down to 26 feet, and then back down to 12. And it did kind of the same thing on the left-hand side. And this is what it will look like in Civil 3D. Profile view, profile right, profile left. Pros uses the geometry editor of a proposed profile to adjust the stations and elevations. It's really quick to open up that geometry editor and just say, hey, instead of station 2 plus 25, make it 2 plus 30. Instead of 12 feet, make it 14 feet. To adjust my width, to adjust what stationing it's making that adjustment at, it's really easy in that geometry editor. Horizontal edits to an alignment are locked in with profile locking. So if you're using 2015 or higher, which most people are, you have that ability to actually lock proposed profiles to the alignment. So if my alignment widens, lengthens, or changes locations, maybe a PI gets taken out, PI gets entered, I have the ability to lock that profile down to my horizontal alignment. Cons, you need to make 2 profile views for the alignment. So I have my surface profile, I have my proposed profile for a center line of road, and that might be up in Minnesota, we're sitting at anywhere from 750 feet to roughly 830 feet, depending on where you're at. So now I got to create a second profile view that will show from 0 to possibly 36 feet. Don't want to do just one big profile view because that thing would be very tall on there, but it's a con. I'm not saying that it's perfect. Create a second profile view, set the values, manually set the elevations to go from 0 to 240 or minus 10 to 30, whatever range you need. Not the end of the world. Another thing, setting the height of a segment from a profile. Right here is a screen cap of a ped ramp. We got curb coming in, and then it drops down to 0 curb and then back up. The same concept is there. I set a target parameter, elevation, so it's vertical, to 0.5, and I call it curb height. I create another variable, CH double for curb height. And in my properties, name, CH double 0.5 on there. Simple enough there. Now what I do is just like with the horizontal from a vertical, is I say, is this vertical target valid? Height 0,1 is valid. There's my variable. Oops, sorry, height 0,1. Right there, is it valid? If it is, it's true. If it's not, it's false. And if it's true, it gets height 0,1 dot value for my CH. And if it's not, it gets the value for my input parameters. Again, CH equals curb height on there. And that's what I see here is my input parameters. I have curb height, double input 0.5. Delta Y is now CH. Instead of curb height, I now go CH because it will either read the value of my profile at that particular station, or it will read curb height and have it hard-coded at 0.5. Again, no overrides are needed at this point because they're pretty much taken right up here in this decision. I'm going to go ahead and jump into the software just to show you what I did. And I have that width. It's a very simple segment. I didn't want to overwhelm anything on here. And first thing I'm going to do is I'm going to look at the input parameters. And I have width 1, slope 1, depth 1. And I have W1 equaling 12 feet. Nothing fancy about that, width, slope, depth. And I have one target. It is an elevation target, and it has a preview value of 24 feet. Call it profile 01. What I did was I created a sequence just to keep this a little streamlined. And I open it up and I set width 1 to equal double. We'll take a real number. And I gave it a default value of 12. The value doesn't really matter much there. Well, then I came down and said, well, is there a target assigned to profile 01? And if it's true, it gets the value of that profile target, profile 01 dot value. So it's pulling this right in here. And if it's false, it gets with 01 equals W1, which W1 is right here, gets 12. And then from there, under the construction of line P2 to and L1, we are just using that system variable that I created over here with 01 to set that value. If I come in and go to my target parameters and say disable, it moved down to 12 feet. If I enable it, it says, oh, yep, it's there, and it's set to 24 feet. It's that simple. Set a vertical target, pull the value from it by reading profile 01 dot value in the decision. Is this valid? Is it valid means, is there a target? And if it is valid, assign that variable the value of that profile line at that station, at that particular point. This one was simple enough. I created another one called curb. I'll go ahead and say no to that. And what I did was, this was a part of the corridor productivity pack from CTC software, and everything was defaulted to 6-inch curb. Well, maybe somebody wants to come in and make 8-inch curb or 4-inch curb, or the biggest complaint with Civil 3D is I need a ped ramp. I need my curb to go from 6-inch down to 0. So what I did was, on my input parameters, I'll come over here, I'll slide that out a little bit. I have my curb parameters in here. I have insert location, lip of curb, flow line of curb, top back of curb, the slope, the width, the depth of top, that's from top face to top back, and then curb height. Curb height, curb underscore height is set to 0.5. It's a 6-inch curb. I also came in and set H01 as an elevation target called curb height. Curb no underscore curb space height here, curb underscore height here. From there, I came in and created a variable CH, short for curb height, made it a double. Then what I did was I checked to see if my height 01 was valid. Just like the horizontal, if it's valid, it comes this way and reads the height of that profile, height 01 dot value. If it is false, it reads curb underscore height, 0.5, 6 inches. From there, it comes through and now it asks, hey, where's the insertion point, flow line of curb, tip of curb, top back of curb, and then it builds the curb, the base, the sub base, and then the common area behind it on there. Simple enough. All we had to do was add a new target, an elevation target, and then create a variable and then a decision, and the variable either reads the value from the target or the value from the input. And of course, this could be as simple as, you know what, just hard code it in. Hard code in 0.5, hard code in 0.75. But I still want my users inside Civil 3D to have the ability to potentially set that curb height. Because, you know what, that target may only be for half the alignment. Well, half that alignment, it's set. The other half, I want my user to pick on there. So from there, I'm going to jump into Civil 3D. And I built 2 basic corridors in here. First one I used is my segment width subassembly. And the other one over here, I just basically used my generic curb on here. What I did was I came in and I'll do the width one first. There is my profile view. And if I click on that, this says surface profile. I didn't really care because I wasn't targeting anything. I just said, hey, just follow it. Insignificant to have a design profile there. But then what I did was I came over and I created a width profile. And you can see both of them in here because they're both got the same station, 0 to 3 plus 50-ish. But this is, the green one is my right. So if I click on the green one, I have width right, and the yellow one is width left. And all I did was I just started out at 12 feet, give or take, came up to 36 feet, over, down, over. Same thing with the left-hand side. I talked about the geometry editor. Click on my line, edit profile geometry. There's my geometry editor. Click on the spreadsheet, widen this out just a little bit. And I can adjust my stationing on my angle points. I can adjust the elevations on my angle points. Very simple. Everything's right here. You know, 0 plus 23, no, 0 plus 25. 36.05, that is such a weird number. Let's just make it 36 feet. 1 plus 29, no, 1 plus 30. And let's go 36 feet again here. And 1 plus 50. And this is going to be 24 feet. That quickly, I just changed 6 variables in a matter of seconds. That line is now updated. I could have done the same thing on the left-hand side. From there, let me close out of this. I went into my corridor parameters. Parameters, set all targets, and I set a vertical target, slope or elevation target for the width right, width left. Now all I had to do was pick a profile. From there, it read the value at station 2 plus 25 and assigned that a value, which then was assigned to my width of my lane to match. And in doing so, my lane comes out, shoots out to now 36 feet, goes to 36 feet, goes back down to 24 feet, and then ends back up at 12 feet. The left-hand side does the same thing. Starts out at 12, goes to roughly, I believe, 14, and then back out. It does a little bit more moving on it than the right one did. But if I look at that, it comes out and hits that. So I had here, here, and here. My curb, again, the curb subassembly right here, built the surface profile for that road. Again, it's just a surface. I didn't build a design, wasn't too concerned about that. But then what I did was I came in and created a pros profile, and the view only went from 0 to 10. If I have something that is bigger than 10-foot curb, now we're talking walls. Anything over 4 foot is considered a wall. But technically, I could take my curb and turn it into a jersey wall by assigning a target up to 42 inches, 3.5 feet. And I just came in and I said, hey, start out at 0.5 and then come down and over. So I'm going to look at this in Geometry Editor. And what it did was at begin station, 0.5, 0.5, went down to 0.1, 0.1, 0.5, 0.5. That's what it did here. 0.5 down to 0.1, 0.1, 0.5, and then over to 0.5. You can't set 0 in there. For some reason, the subassembly doesn't work, but setting something like 0.05, 0.02 does work. Something bigger than 0 works. Because there is always that small lip on there, I put mine at 0.1. So there's my proposed profile. I'm going to go ahead and close out of this, close out of that. Going to jump in to my corridor property. Parameters, set all targets. And in here, I have an elevation target for curb height. Curb height equals curb height 2. Say OK. Say OK. And at that station, which I'll have to take a quick peek again, that station roughly 1 plus 72 is my curb. 1 plus 72 is right about here. and you can see the line slightly bend in away from the blue line. There is my ped ramp on there. If I go ahead and click on this and go into Object Viewer, and we'll test my skills out here. We'll go with 3D hidden. There is my ped ramp. I was able to see and build that ped ramp using that proposed profile. What that means is when I know I'm going around the curb return, I know where that ped ramp is at. So I'm having everything based off of that. I did get a question, just a thought, instead of using profiles, could you use offset alignments? That way you could more easily see where the curb transitions will be. Yes, I could come in and create an offset alignment and then create a profile off of that to drop it down. Makes it a little bit easier than I'm not doing two profile views, but it would still be something that targeting that profile line, setting it to 0.5 down to 0.1 is the key on there. I don't want to come in and say set to elevation because my curb may be at an 800 foot here, but it's at an 800.2 here, and then an 800.25 here. It's hard to set a value, a target elevation off of that. Setting a profile view for the elevation is much better on there. But yes, setting that to 0.5 down to 0.1, 0.05, whatever you want your lip to still be, and then back up, it works on there. So that was two examples that I used. Creating a horizontal target from a vertical, and then setting the height of an object inside the target based off of another object. Let's hear. I meant target the offset alignment to get the curb height. The alignment is offset 0.5, so the curb is 0.5. Alignments are for horizontal. I would have to target a profile then. Oh, I think I see what you mean. We create an offset alignment at 0.5. Oh, yep. The curb is 0.5, the offset is 0.1, so the curb is 0.1. So, all right, I see. Yeah, we could come in and create an alignment that is 0.1, an offset alignment of 0.1, read that value, and then apply that there. So, both ways work. I was looking at profile lines, profile views on there. What does this mean with the Corridor Productivity Pack? Again, you have that ability to do what I just did. Download the Corridor Productivity Pack from ctcsoftware.com. It is free. There's about 11 PKTs out there. And with the fact that they are exactly PKTs, you have the ability to open them in Subassembly Composer, and you could come in and make these adjustments to it. You saw what I did, created a variable, created a decision, created another vertical target, and if the vertical target is valid, it goes true. If it's false, it goes and uses the input parameters. I like it for ped ramps or switching from full curb to surmountable curb, kind of a ped ramp. My subdivision, where I live, everything is surmountable curb except for at the corners and at the catch basins. I have my curb return, and then I have 10 feet of full curb, and then it transitions over roughly about 5 feet into surmountable curb. I could do the exact same thing here. And then add vertical target for the width of the sidewalk sections. The min-dot curb or the curb with sidewalk and boulevard, I can set a proposed profile to set the width of my inside boulevard, outside boulevard, or even the sidewalk. And then there is a median also, and then the multi-layer lane to mark point. I'm gonna quickly get out of this. And I meant to have this open right off the get-go. And this is what I'm talking about. You go to ctcsoftware.com, products, corridor productivity pack, download for free. And what it is it'll give you these 12 subassemblies, one being a median, which will give you a varying width in there. And if the width gets wide enough, you will get two separate bases or sub bases under here. But when they're close enough, it creates one. Multi-layer link point, what this does is gives you an option of 1, 2, or 3 lifts for bituminous, then base, then sub base. Instead of just using the lane super elevation AOR, where you always get 2. Well, now what happens when I need 3? Now what happens when I need 1? This gives you 1, 2, or 3, and it will target a mark point to build. The general curb, great one to add that height for the height of the curb. Min-dot curb gives you the 4 different styles, B, V, D, and S. Most state curbs are very similar to the same. So you could download the min-dot curb, and it would probably be the same thing for someone out in Colorado, maybe even Arizona, or even Florida, in terms of those 4. And this is the one I was talking about, the vertical target for a horizontal width. The min-dot curb with sidewalk. What this does is it gives you curb, sidewalk, boulevard, sidewalk, sidewalk, outside boulevard, and then common. Hey, now I have to backfill after I put my curb in. What do I need? The other nice thing about this is these 3 are all independent for slope. Whereas the out of the box sidewalk, if you set 2%, all 3 segments are 2%. This gives you the ability to say 2%, minus 2%, minus 4% on there. Sidewalk with boulevard, same thing, just no curb. From the right-of-way, so you have a mark point to fill in the gap. And then these are the generic link with link slope to surface, but now you have depth. Link width and slope, but now you have depth. Link slope with vertical deflection, but now you have depth. And then slope to elevation, depth, mark point, depth. So some of them are just generic, but they give you the ability to get depth, which now I can get quantities out of there. I could take this free corridor productivity pack from CTC Software and apply these little tricks that I just showed you today to make these subassemblies that much better. And like the one that I showed here, this curb one in here, this one is I took it one step farther and I actually went with 3 different locations for the curb on there. I didn't get any other questions. So with that, I'll go ahead and say thanks for attending. I appreciate you guys hopping in. I appreciate the questions, and keep an eye on our website for future webinars.